Hello. This video is about making a 4-bit adder in Minecraft. It is for creative mode, as you could, and should, definitely make a better, smaller one in survival. This design should work on any Minecraft version that has redstone, as it uses 0 comparators, which were added in a later update. First things first, what do you need? Well, you need redstone torches, repeaters, levers, wool for organization, redstone lamps, and the block your floor is made of, or just any block in general for design. I'm going to show you the 3 types of gates you will need for the build. The first one is the OR gate. In Minecraft, you can just connect 2 inputs into one to make an OR gate. When both inputs are 0, the output is 0. When one is 1, the output is 1. When both are 1, the output is also 1. Next is the AND gate. The design is quite simple. When both inputs are 0, the output is 0. When one input is 0, the output is also 0. Both inputs have to be 1 for the output to be 1. Next is the XOR gate. This one is the most complicated. When both inputs are 0, the output is 0. When one is 1, the output is 1. When both are 1, the output is 0. This differs from the OR gate, as when both are 1, the output is 1 for the OR gate. Okay, so now that the gates themselves are explained and out of the way, how was the full adder actually built? Well, I have the beautiful platform of MS Paint up to show you a design of one. There are 3 inputs, A, B, and C in. All 3 of these have a value of 1. A and B are the actual numbers that are put in, while C in is the value of the adder before it. C in stands for carry in. There are also 2 outputs, S and C out. S stands for sum, while C out stands for carry out. S has a value of 1, while C out has a value of 2. In the actual logic are the 3 previously mentioned gates, OR gates, AND gates, and XOR gates. To start, there is XOR gate number 1 connecting A and B. Next to it is AND gate number 1 connecting A and B. Next, there is XOR gate number 2, connecting the output of XOR gate number 1 with C in. Then, there is AND gate number 2, connecting the output of XOR gate number 1 with C in. Lastly, there is OR gate number 1, which connects the outputs of AND gate number 1 and AND gate number 2. XOR gate number 2 goes to sum, and OR gate number 1 goes to C out. How are these adders actually connected to make a 4-bit adder? Well, the first adder has 2 outputs, one of which goes to the next adder. Sum goes out to one of the display lights, or just any output in general, while C out is the one that proceeds onwards. This is how it works all throughout the system until you reach the last adder. With the last adder, as there is no adder in front of it, you either throw away C out or use it as a 5th output. I'm going to keep it. For each adder, you connect the actual inputs, A and B, into a user interface. Levers in my case. The first 2 go into the first adder, the second 2 go into the second, and so on. It doesn't really matter if you switch the 2 inputs for each adder up, unless you want organization, so probably not. First things first, you need to build the inputs. I will show all inputs, including C in. You start with A and B, represented as levers, and put them a couple of blocks away from each other. A couple more blocks away is C in. Making the first XOR gate is pretty simple. Just use the design from earlier, connecting A and B. Make the AND gate a couple of blocks to the side of that one, also connecting A and B. In front of XOR gate number 1, put the second XOR gate, a couple of blocks in front of the first. The inputs for it are the first XOR gate and CIN. Connect a redstone lamp to the output of it. This is the sum output. To the right of the second XOR gate, put the AND gate, with its inputs being XOR gate number 1 and CIN. In front of that is the OR gate, which is just 2 pieces of redstone connecting. Put the outputs of both AND gates into it. Connect the redstone lamp to the OR gate. This is Cout. That is the entire full adder built. Test it and see if it works. If it doesn't, check the signal strength of the redstone throughout to make sure it is correct. Make sure to delete temporary levers in front of this adder, as they will be added later in the full thing. Next up is the 4-bit adder building process. The adder will be duplicated, so choose how you want to line them up. Either do a straight line, which is easier to make, but takes up more forwards room, make 2 of them backwards facing the front, which is probably the best in terms of space and difficulty, or stack them on top of each other, which is by far the most difficult, but it will take up the least space. Duplicate each adder either by hand or using a structure block, until you have 4 of them total. Starting with the 4 adders, connect Cout of one into CIN of the other. Connect sum later. Repeat connecting Cout into CIN until you reach the 4th full adder, where you should just leave the Cout port alone for now. Make a wall of levers with 4 on the top and 4 on the bottom, making sure to space each one out appropriately. Usually about 2 to 3 blocks in between each. The rightmost levers go to the A and B values for the first and closest full adder. The levers left of those go to the second adder. The levers left of those go to the third, and same with the fourth. Finally, take the sums of every adder and the cout of the fourth adder and line them up so that they are all easily visible from the wall of levers. Make the sum output of the first adder the rightmost in the line, the sum of the second 1 from the right, the sum of the third 2 from the right, and so on. Make the cout output the leftmost one in the line. Connect a redstone lamp to each. The input-output system should be done. If If this system isn't working, check the wiring and see if there are any low signal strength redstone pieces.
Now on to the actual function of it. These are bits 1, these are bits 2, these are bits 3, and these are bits 4. 1, 2, 3, 4, and 5. Bit 1 has a value of 1, bit 2 has a value of 2, bit 3 has a value of 4, bit 4 has a value of 8, and bit 5 has a value of 16. This currently represents 0 plus 1, which equals 1. This is 1 plus 1, which equals 2. This is 1 plus 2, which equals 3. This is 10 plus 6, 8 plus 2, and 4 plus 2, which equals 16. Or it should. It equals 17 right now for some reason. Checking the wiring, this repeater is incorrect. Now that that's fixed, time for more equations. This is 14 plus 3. 8 plus 4 plus 2, and 2 plus 1, which equals 17. 16 plus 1. Now, time for everything. 8 plus 4 plus 2 plus 1, which is 15, and 15 again. This equals 30. 2 plus 4 plus 8 plus 16.
Thank you for watching this video. If you need any clarification, post it in the comments and I'll try and help you out. There is another video I made earlier, but it doesn't really go that in depth. But you should totally watch that one.